Good morning students, welcome to the class of Technomathematics. So today we will see and solve a numerical based upon the concept of displacement and distance. So here a circular track is given whose diameter is 200 meter, right? And an athlete is taking a round, just run about the circular track in and completes one round in 40 seconds. We need to find at the end of 2 minutes and 20 seconds what will be the distance and the displacement as covered by the athlete, right, from the starting point. So let us see, this is the diameter which is 200 meter, which is 200 meter as given into the question, right? Now what we will do, we will just mark it in our question in the shown diagram over here, the diameter is 200 meter, right? Now let us say this is the athlete. I know the figure of the athlete is not very good, but don't mind. You should consider that this is an athlete, right? Okay, got it. Now this athlete is just taking, is just running around the circular track in this way across the circumference of the circular track, right? So this is the circumference which I am just marking over here, right, by the red lines, red arrows. Through the red arrows the athlete is running, right? So it completes one round in 200, one round in 40 seconds, whose diameter is 200 meter, right? Now we can see in one round how much distance is covered by the athlete, right? The distance as covered by the athlete in just covering one round of the circular track is how much? Definitely it will be the circumference of the circular track, right? And we know that circumference of the circular track can be calculated very easily. Why? We know that circumference of a circular track is 2 pi r. This is the formula. What is the formula of circumference? 2 into pi into r, where the value of pi is known as 22 pi, 22 by 7 or 3.1414, or r is the radius of the circular track or any circular figure which is in the question, right? So 2 pi r is the circumference of the track, circular track, and when the athlete covers one round across the circular track, then definitely it covers a distance of 2 pi r, which will be coming as 2 into pi into r. R will be 200 divided by 2. Why? Because diameter is given as 200 meters, so radius will be half of diameter, and we can see 200 by 2 is the radius. 2 will cancel out, and 200 pi is our distance which is covered by the athlete in when he runs around one time across the circular track. So across, when he completes one round across the circular track, the total distance as covered by the athlete is 200 pi meter, right? 200 times pi. Actually I have not just solved into decimals, because you can just calculate it, just multiply 200 into 3.1414, you will get it, right? So I'm just not going into the details of the calculation, I'm just mentioning it as 200 pi, right? I don't think it will create any problem, right? And now what we will do, the second part, the second part of the question, you can see the athlete took, since the athlete took 40 seconds to complete one round, so we'll just apply the unitary method. What is unitary method? We will calculate the distance covered by the athlete in 1 second, right? Since the athlete took 40 seconds to cover how much distance? Athlete took 40 seconds to complete the circumference, that is 200 pi, right, which we have already calculated above, right? So in 40 seconds distance covered is 200 pi, right? So we can write it as 40 seconds, in 40 seconds distance covered is equal to 200 pi meter, right? So 200 pi meter, right? So in 1 second, what will be the distance covered? This is the unitary method. We will calculate for the unit measurement, unit quantity, then multiply with the required one. So applying the unitary method, we see in 1 second the distance covered by the athlete is equal to, in 1 second the distance covered by the athlete is equal to 200 pi, which is into the RHS. This will be divided by 40, because 40 is into the LHS and 40 seconds can be written as 40 into 1 second. So leave 1 second into the LHS and bring 40 into the denominator of the RHS. So 200 by 200 pi divided by 40, and in the table of 40 you can cut 200 as 5 times and 40 as 1 times. 40 into 1 equal to 40 and 40 into 5 equal to 200. So 5 pi. So we can see that athlete took 40 seconds to complete 200 pi, and athlete in 1 second the distance covered by the athlete is 5 pi meter, right? So just mention over here that 5 pi meter is the distance which is covered by the athlete during running in 1 second, right? Now the second part of the question which I was mentioning earlier, that the at the end of 2 minute 20 seconds, what is the distance and displacement? So what is exactly 2 minute and 20 seconds? Let us convert this into seconds. Just convert minute into seconds and add the 20 seconds to the 2 minute of seconds value, right? So 2 minute 20 seconds is equal to 2 into 60 plus 20, which will be coming as 140 seconds, right? I already shown over here, right? So the distance covered by the athlete in 140 seconds is how much? The distance covered by athlete in 1 second is 5 pi. So definitely the distance covered by the athlete in 140 seconds is will be the same value of 5 pi multiplied by 140, right? Perfect. So what we will do, just multiply 140 into distance covered in 1 second, right? Distance covered in 1 second. So distance covered in 1 second is 5 pi, right? So just put up the value over there, right? 140 into the distance as covered in 1 second is 5 pi. So 140 into 5 pi. Just write over here into 5 pi, right? So leave pi as it is, and 140 into 5 will be 700. So this will be coming as 700 pi, 700 pi meter. This is the distance which is covered by the athlete in 2 minutes and 20 seconds. I hope this is very clear to you, right? Perfect. So the distance covered by the athlete in 2 minutes and 20 seconds or 140 seconds is 700 pi meter, right? So since we have to calculate two part, we have to find our answer consists of two parts. We need to calculate the distance, we need to calculate the displacement. So 700 pi is the distance which we have already calculated. I have written over here, right? I have tick marked it. So for the displacement, we know that displacement is the shortest distance between the starting point and the finishing point, right? So if the athlete is starting from the leftmost point, which I have shown over here by just marking him as a diagram in the diagram. So the displacement of the body of the athlete in 2 minutes and 20 seconds. So just look over the first part of the question, that in 40 seconds he is completing one round. right? So just I'm mentioning over here, in 40 seconds the athlete is completing one round, right? One round. So number of rounds, number of rounds he will complete in 2 minutes and 20 seconds will be how much? 2 minutes 20 seconds is 140 seconds divided by 40. This will be the 40 is the time of completing one revolution across the circumference, that is completing one round of circular track. So divide 140 by 40. Dividing 140 by 40 will give you the number of rounds which is completed by the athlete in 2 minutes and 20 seconds. So this will be coming as 3.5. This will be coming as 3.5. So in 2 minutes and 20 seconds the athlete completes 3.5 rounds, right? 3.5 rounds, right? So just I have corrected over here because it was not very much readable, so I just mentioned it very clearly, right? So 3.5 rounds will be completed by the athlete in 2 minutes and 20 seconds. So we can say that, so we can say that 3 complete round plus half, that is 0.5 round, zero point 0.5 complete round and 3 complete round and half, that is 3 and half. So when he completes the 3 round, he will just reach to the position from where he already started. So as soon as he covers the third round, at the completion of third round the displacement will be zero, right? But he covers 3.5 rounds, so definitely in the last half round where he will be positioned exactly at a distance of a diameter that is exactly opposite to the starting point of the athlete, right? So in in the in the in this 3.5 rounds, we can say in 3 rounds the display in completing the 3 complete round, the 3 whole number, after completing the 3 complete revolution, right, the displacement will be zero, and the our answer will lie into the 0.5 round which is covered after completing, after reaching the starting point, right? So this will be the distance, or as this is the distance which is from the starting point and as covered in completing 0.5 round. So this will be our displacement, right? So we can say that in this figure as highlighted in yellow, as he completed 3 rounds, he reaches to the original position. At the end of third round, the displacement is zero. So the final displacement will be that value as it covered during 0.5th round, that is during the half of the balance round above the third round, right? So in the last part, that is above the third round, after completing the third round, the displacement will be coming after completing the third round will be zero, and the final displacement will be exactly in the last 0.5th round, he will be positioned exactly opposite to the starting position. So what is the, that the displacement is the shortest distance between the starting point and the finishing point. So this will be the distance of, he will be at a distance of diameter, and diameter is 200 meter, right? So displacement of the athlete after 2 minutes and 20 seconds will be equal to the diameter of the circular track. So 200 meter is the displacement, right? So we have calculated the second part of the question, right? This is our answer. 200 meter is the displacement of our athlete in 2 minutes and 20 seconds across the circular track. Thanks.